So what is first order phase transition? During first order phase transition, there will be change of state from like solid to liquid or liquid to solid, liquid to vapor or vapor to liquid, or directly from solid to vapor, etc. That is melting, where there is a change of phase from solid to liquid. And then there is freezing. Freezing means there will be change of phase from liquid phase to solid phase. Then there is boiling, liquid phase to vapor phase, condensation, vapor phase to liquid phase, and then sublimation, solid phase to vapor phase, direct conversion. Okay. So now during this phase transition, it is observed that during this transition, temperature and pressure remains same. Like you have seen in Andrews experiment with carbon dioxide, when there is a change of phase, that is from vapor or gases, from gases carbon dioxide we got liquid carbon dioxide. During the transition phase, the temperature and pressure remains constant, and both the phases existed in equilibrium. So during first order phase transition, if both the phases are coexisting in equilibrium and temperature and pressure are constant, then what happens, that specific Gibbs free energy remains same. That is, if phase 1 specific Gibbs energy of phase 1 is G1 and specific Gibbs free energy of phase 2 is G2, then G1 is equals to G2. So what is specific Gibbs free energy? We know what is Gibbs free energy. Then Gibbs free energy per unit mass is called specific Gibbs free energy. So during first order phase transition, when a substance converts from phase 1 to phase 2, then specific Gibbs free energy of the phase 1 during the transition phase, when the transition just happens, that is, suppose the solid converts into liquid, then specific Gibbs free energy of the solid substance will be equals to the specific Gibbs free energy of the liquid substance. Okay, and that we can express in terms of a graph. That is, if we plot specific Gibbs free energy with respect to the temperature, then we'll find that this specific Gibbs free energy, it is changing continuously, and this dotted line indicates the phase transition. It is this side is phase 1, this side is phase 2, and during the transition, at the point of transition, G1 is equals to G2. So this change is continuous, there is no abrupt change. But during such transition, there will be some abrupt finite change in the first order derivatives of Gibbs free energy. Okay, so we know the first order derivative del G del T constant P. We know Gibbs free energy is a function of pressure and temperature. So if we take first order derivative of G with respect to T, keeping pressure constant, we will get entropy. Similarly, del G del P constant T is V. So here, as we are taking this specific Gibbs free energy, these quantities small s and small v are specific entropy and specific volume respectively. Okay, so during this first order phase transition, what is observed, that there will be an abrupt finite change in entropy and specific volume. So during such transition, there is a discontinuity. What we observe? A discontinuity in the first order derivatives of G, that is in specific entropy and specific volume. And we can also express these abrupt changes through graphs. So how do you do this? It is like this. So here you observe that here we are plotting specific volume with respect to absolute temperature T. So this side is phase 1, this is the transition phase, this dotted line indicates the transition phase, and this side is phase 2. Like here we have the completely solid phase, this side liquid phase, or this side is liquid phase, this side is vapor phase, whatever. Then what we observe, that as temperature increases, volume increases. As temperature increases, volume increases. Then suddenly, so here the transition starts. The substance starts converting from phase 1 to phase 2, and when the conversion is completed, we have completely phase 2. Suddenly we see that its volume is changed to V2. So initially it was, the volume was V1, suddenly it is V2. So there is an abrupt finite change in the specific volume. So this indicates the discontinuity. Similarly, for specific entropy, what we have? This side is phase 1, this side is phase 2. This indicates, the dotted line indicates the transition phase. So with temperature, entropy of phase 1 is changing. Here the phase transition starts, and suddenly when the phase transition is completed, we observe that the entropy has suddenly changed from S1 to S2. So this also indicates a discontinuity. The change is not continuous but sudden. There is a sudden change at the same temperature T. So during the transition phase, the temperature remains constant. Here we have phase 1 with entropy S1. When the phase transition is completed at the same temperature, what we observe that the entropy is suddenly changed to S2 for phase